have a feel of uh, classroom learning. So today we'll be starting the discussion on the subject, that is theory of computation. Okay, so we will very first try to understand what is the meaning of each word and what is the purpose of this subject, and third thing, why this subject is included in your syllabus. So very first is word theory. So you already know what is the meaning of theory. So next is of, and then there is a computation word. Okay, so computation word is also very commonly understood to you. You are using it very frequently. You have applied this. Okay, so once you started using the calculator, you have started doing the computation. So calculator does the computation. What is your say? Or it only calculates? So the modern calculators does computations as well. So what is the difference between calculation and computation? So in calculation, we are generally working with the mathematical operations, while in case of computation, you are moving or you are doing more than that, where you are applying logic, you are using conditions, you are applying loops, you are writing programs. Okay, so set of instructions you are processing to get certain output. Okay, so exactly in this subject, we are going to learn how this computation or programming started. What was the very ancient model? How it was actually done? So it is not a computer architecture. There you learned uh, what was the machine structures, what was the instruction formats, okay, what type of internal structure which are carrying information from different units. So we are not talking on that. We are talking about how exactly the programming is existed, how it is started, how the computation through the programming, okay, is started. So start from the starting. So you know that now when I relate this computation with the programming, so I can say that if I want to do programming, I want to use some language. Are you getting right? So if you want to do programming in computer engineering or with the computers, you need a language. Now, what is the difference between the languages which you are using and the computers are using? So you have already learned that there are low level languages, middle level languages, high level languages, right? But if I want to understand languages in general way, then language is nothing but set of words and a grammar. Okay, now if I want to relate these two things, okay, so if I talk about a Hindi language, whether it is having its own set of words, yes, whether Hindi language is having its own grammar, yes, it is having. Similarly, if I take any language which we are using for communication. So what is the purpose of language? To have a communication. So programming languages are used for what kind of communication? Between human and the computer, right? So now, whatever kind of languages we are talking about, the purpose is for communication, and it is having set of words, and it is associated with its own grammar. The grammar of English language is not applicable to the grammar of Hindi language or Marathi language. Okay, so as soon as you design any language, okay, it is required that you should very first find out the set of words or identify the set of words, and you should also define the grammar to use that language, to understand that language, to create sentences from that language. Are you getting? So language is having set of words and grammar, whether it is a daily life communication language or whether it is a programming language, right? So language is having set of words and set of grammar. If we talk about set of words, so in set of words in Hindi are composed of set of akshar, I can say, right? Okay. And if I say it is an English language, then it is nothing but set of alphabets, right? So similarly, every language is having set of words which are formed from another small uh, symbols, we can say, and those are defined in their own language as either akshar or alphabet or xyz. Now when we talk about the languages which we are going to learn in this subject, so this subject is all about the language generation and language recognition. Okay, so when we talk about language generation, so we require some machine which will generate a language. Okay, and when we will say I will generate a language, because if we can define set of words and if we can define grammar, then we will say that we have generated a new language. Okay, now recognize language. So machine, if we give any input, suppose I give one sentence, okay, in Hindi, and I will have one machine which will recognize whether this sentence is a valid sentence or not. So I need a Hindi recognizer, sentence recognizer, which will take these all shabda or words, and one by one it will check whether they are valid words, and next it will check whether those words are properly organized so that it is forming a meaningful statement, meaningful sentence, right? So here, when we talk about a language, so in this subject we are going to learn about languages which are generated by different machines. Okay, and when we talk about a languages, then we need to have these two information: what will be the set of words in that language and what are the set of what is the grammar rules. Okay, so in our formal languages, whatever we are talking about and trying to understand, in the formal languages, what is a formal language? So we will be defining, is it visible? Yes, formal language. Okay, so prior to define this could be again a question in the paper, how to define a formal language. Okay, so before defining proper formal language, we need to understand some basic concepts. What are the basic concepts? We need to define certain terminologies. Very first is the symbol. Okay, so what is a symbol? Symbol is an abstract entity. It cannot be defined formally. What exactly this means? So for example, with this example, it will be clear. For example, the letters, digits, okay, all these are the symbols. Okay, to these are the symbols which you want to consider for designing any language. For example, in Hindi, what is the symbol? So all akshars are acting as symbols which are forming a word. Similarly, in alphabets, you are having the A to Z alphabets. Okay. So here in our language, we will be defining alphabets in another way. But in our formal languages, we are defining very basic unit of a language is an abstract entity and it cannot be defined formally. So you can have example as what? Example letters and digits. Okay. Then second definition which we are going to learn is the alphabet. What we represented, how we represent. So second definition is alphabet. So what is an alphabet and how it is defined or denoted? It is denoted by summation sign. Okay. So this particular symbol we are going to use throughout the subject. So you should remember that alphabet is nothing but denoted by summation, and what it is nothing but it is a finite set of symbols. Okay. So as opposed to alphabet in English, okay, we are saying that it is nothing but a finite set of symbols. For example, if I want to have the alphabets for any uh, language, okay, so they will be represented by a symbol, and each symbol will be like 0, 1, 2, 3. So these are the digits set. Similarly, I can define any set. It is a finite set of symbols. Which are the symbols? 0 to 9 are the symbols. Now I can have any set which is a set of operators. Okay. So like this, I can have another set as y is equal to A, B, then D. I can have any dollar, or I can have at something like this. So this is my own way to define any alphabet for any language, and it is the concern of language designer which symbols they want to include for their language. So I hope this is clear to you. So what is alphabet? It is a finite set of symbols. Okay. What are a symbol? These are the entities. Okay. Now third is the set. What is a set? It is nothing but collection of objects. Okay. So just remind me the time. Okay. So we have 5 more minutes. Like it is collection of objects without repetitions. Okay. Now I'm not going to discuss this in much detail because you have already learned sets in the discrete mathematics. Okay. So I would directly like to move to the definition of the. So I hope you understand or recall all the relation like transitivity, closure of relation. You have learned all this. Okay. So I'm moving to next definition, that is a string. So what is a string? As usual, you know the meaning. This is also called as a word. In our discussion, we will also use the word as the string to specify the string. So what is a string? So string over an alphabet. So how we define the alphabet? Summation. So we can form string from this set only. I cannot use any of these symbols to define string over an alphabet Y. Are you getting? So a string over an alphabet. So this is my summation. This is another summation. It is another alphabet, right? So this is one alphabet. This is another alphabet. This is another alphabet. And if I want to form string, I need to use only set symbols which are available in this alphabet. So a string over an alphabet is defined as any finite sequence of symbols from alphabet. Here, so for example, if I am saying that x is equal to ABC, so for this I should have some alphabet. Suppose I am having an alphabet which is denoted by A, B, C up to Z. So this is one set. Over this alphabet, I have defined one string which is nominated as X, which is nothing but collection of, with a proper sequence, the symbols in that particular alphabet. So X is representing a string over an alphabet summation. I can name it as, for example, A. It is alphabet. Okay. Now, if I want to know the prefixes of X, then it will be nothing but empty string. So I think you know how we define the empty string with the epsilon, then A, AB, okay, and ABC. All are the prefixes to the string ABC, and proper prefixes will be the empty A and AB. Okay, so in this way we define the string. If we want to define the suffixes, so suffixes will be what? Empty, C, BC and ABC. These are the suffixes for the given string X. Okay, this is all for X or X. Okay, so I think you have understood the meaning of all this. Now only last definition and then I'll stop. The last definition is the language. Which we are trying to define formally. So a language is defined as a set of string of symbols, okay, strings of symbols from one alphabet, okay, where null set, okay, and the empty string is called as empty string. Okay, so null set or empty string are also the languages. So if I will ask you the question whether this is representing one language, so you should say yes. If I am saying empty string, Is it a language? Yes. If I'm saying set of some A, B, A, then X, Y, something like this. Okay, this is a language. So yes, this is also language. So what is a language? It is defined as a set of strings of symbols from one alphabet. So I have considered suppose alphabet A to Z. Okay. So whether this is representing language, yes, it is. It is also representing a language, and it is also the set of valid strings of symbol. Then it is also, even I can consider empty string A, B, something like this also a language. Okay. So formally we can say that the set of all string over a fixed alphabet. It is a set of strings over fixed alphabet. Okay, and it is denoted by the summation star. If it is a uh, infinite language, so for example, if I am having alphabet as A, then its closure, I think you must have learned this, its closure will be what? Empty A. So in this alphabet you are having only single symbol. So all possible combination of that symbol comes under the closure of any set. So this is set theory actually. This is a closure of this set. Okay. So this is representing one language. So it is having set of strings formed through the symbols in the alphabet. Right. Similarly, if I can take another example, for example, it is having 0 and 1. Okay, only these two symbols. Then I can form an infinite language from or over this alphabet as empty 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. So it is an infinite. So it will be denoted like this. So it is again a closure of this set, and we can say this is representing language over this. Now, formal language is referring what? The fact that all the rules for the language are explicitly stated in terms of what string of symbols can occur. So, formally, formal language will be, it will be the word formal refers to the fact that all the rules for the language are explicitly stated in terms of what strings of symbol can occur. For example, I tell you, here we have defined this language which is having the rule as what? It is a language where A can occur 0 or more number of times. Okay. Here it is a language which is again a closure of it, where it says that again the combination of 0 and 1 can come in any sequence any number of times. But if I change, so here it is written explicitly defined. When I talk about explicitly define the rules, so if I say that I want to form a language which is having all the strings having length 2 over an alphabet summation. See, once again repeating, I want a language in which all the strings are having even length. okay, over an alphabet A. So my language will become, suppose I'm defining that in terms of B, so it will be what? A, 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 A. So see, all strings are having even length. So it is also a infinite language because I can define any number of strings. This is one string, is it? So where is, this is your string, right? This is your symbol. Okay, so using this symbol I am forming strings. Similarly, using this symbol I have formed all the strings, and as per the rules stated for the language, that the string length in the language must be even. So I can have only this set of strings. Are you with me? So in this way we can define a formal language where we need to inform explicitly what rules are there to define a language. So I hope